Hi students, good morning. Welcome back to our physics classes. Last class, during the last few classes, we were talking about AC current and AC circuits. And we have finished up with that chapter. And in the last class, I already told you that is the end of the first session of your syllabus. And now we have to start with a new topic, and that new topic is somewhat new concept in physics also. In the sense, suppose when we were talking about the syllabus from the beginning, when we are talking about the syllabus from the beginning, we have started with describing what is a charge, and we have seen how a matter can be, or how matter can be charged, and what are the properties of charge, then interaction between the charges, how they can interact through electric field, they can interact. So the force between them, I mean interaction through the force, that force is given by Coulomb's law. Then electric field and electric field intensity are vector quantities. So to deal with, we have to convert into vector quantities into scalar quantities. So we have converted electric field intensity into electric potential. Then we have seen what is potential and a special kind of system called dipole with the charges. Then how you can store charges. So we need to design a device to store charges, that is capacitor. So that includes in electrostatics. What is charge and the properties of charge, and finally how you can store the charge. Then you talked about how you can accelerate a charge. So when you are accelerating a charge, you will get electric current. So you started with the second unit, that is current electricity. Then you have seen the properties of current, resistance, resistivity, Ohm's law, Kirchhoff's laws, analysis of an DC circuit using Ohm's law or Kirchhoff's law, then potentiometer, meter bridge, all came under the byproduct of electric current. So in the first unit we talked about charges at rest. Second unit we were talking about current electricity, that is charges under motion. See, from the end of that unit, we came to know that besides this electric current, when a charge is moving, it shows some special properties called magnetism. So then we followed that concept of magnetism, how magnetism can be generated, what is the magnetic effect of current, and then we move along with some magnetic aspect of current. Then we went to the realm of magnetism, and we came to know that magnetism can be generated from electricity. That is the magnetic effect of current. Then we have defined magnetizing field, intensity of magnetization, then properties, magnetic materials, diamagnetic, paramagnetic, ferromagnetic, all these materials we have seen. And at the end of those discussions, we came to, we have a hint that when magnetism can be generated from electricity, why it is not possible in the reverse way? That is electromagnetic induction, or that leads to electromagnetic induction. So we have followed the concept of electromagnetic induction, and whenever the magnetic flux associated with an system or a circuit changes, electricity is generated in that. That is induced EMF, and what are the properties of induced EMF, all those matters we have seen. And finally we arrived at a conclusion that how you can change the magnetic flux associated with a coil. Either you can change B, either you can change A, or either you can change theta. So how you can change the flux by changing the theta. So you have conducted an experiment, or you have conducted a coil experiment. Coil is rotating by changing the theta, so electricity is generated. But you came to know that whenever you are generating electricity by changing theta, the induced EMF is alternating EMF. That is the basic of AC circuit analysis. And we have already talked the properties of AC circuit, AC current, AC voltage, and the power, all those matters related to AC we have discussed. So remember from where you have started and from where you are now, or where you are now. So it came to, or it is in our hand now, or that concept is now with us. That means whenever a charge is at rest or charge is under motion, it shows different properties. Similar charge, when it is kept at rest or when it is set into motion, it shows different properties. See, an accelerated charge can generate energy. Accelerated charge can generate energy. See, when a charge is accelerated, when a charge is getting accelerated using cyclotron or any accelerators, one of the examples we have seen, that is cyclotron. So particle accelerators are there. When we are having a particle accelerator and a charge is getting accelerated, it possesses energy. And whenever a accelerated charge possesses some energy, sometimes it radiates its energy, or it gives out energy in the form of radiations. Those radiations already observed by scientists. Some radiations are coming out when charges are getting accelerated. And very familiar that kind of a radiation is our light, visible light. But along with this visible light, scientists discovered too many another radiations. These are also coming from some special situations when the charges are getting accelerated. These radiations are coming out. And they have listed out a series of that kind of radiations. And earlier they were not knowing how these radiations are generated, and but they found that there are some common properties between these radiations. There are some common properties between these radiations. So when we find people having similar behavior, sometimes we will think that they are coming from the same family. Is it? Similarly, scientists also included all these radiations which are showing some similar properties as a single family. But still they don't know from where, which family they are coming from. So many studies done over this concept, and finally it came to know that these radiations are generated from accelerated charge. So what is the special property of an accelerated charge? What is a special property of an accelerated charge? Many times we have said that whenever a charge is at rest, it can provide only electric field. But when an accelerated charge is there, one question was there in your first semester exam. An accelerated moving charge is there. That moving charge means accelerated charge. Moving charge, all the movements are not accelerated motions. But anyhow, accelerated charges are there. These accelerated charges can generate, or moving charges can generate, both electric field as well as magnetic field. And their properties are like this only. These electric field and magnetic field generated are acting perpendicular to each other. They are acting perpendicular to each other. Electric field and magnetic field. They are perpendicular to each other. So whenever you are having a accelerated charge, that accelerated charge is accompanied with a simultaneous electric and magnetic field which are acting normal to each other. I already told you the name for that such kind of electromagnetic fields in Lorentz force in cyclotron. So such electric fields are known as crossed electromagnetic fields. Crossed electromagnetic fields, which means electric field and magnetic field acting perpendicular to each other. Okay, so whenever there is an accelerated charge, they are having both electric energy and magnetic energy. They are varying, means when a charge is moving means a current is there. That can generate a varying magnetic field. Varying magnetic field generate a varying electric field, or a varying electric field can generate a magnetic field. In the sense they are correlated, electric field and magnetic field. Anyhow, when such a closed electromagnetic field is there, from the energy is liberated in terms of or in the form of some radiations. And that radiations are already scientists discovered and made it into a family. And now they called that family of radiations, which are having some common properties, which are generated from accelerated charges. They are called, or they are generated from a closed electromagnetic field. So those radiations are called electromagnetic waves. They are called electromagnetic waves. So electromagnetic waves are a family of radiations. Electromagnetic waves is a family of radiations. They are having some common properties, and those common properties are shown by all the members in that family. Some common properties are there. That common properties are shown by all the members in the family. But individually they are having their own properties also. Means just like a family members, means commonly they are coming from a family, but they are individuals, they are showing some individual behavior also. Similarly, these electromagnetic waves are coming from the same family, but they are having their individual properties also. All these electromagnetic waves are not generated from the same method. Are you getting me? Although we are saying that they are coming from electromagnetic field, closed electromagnetic field, we can't say that all these radiations are generated from the same method. They are having their own origin, but they are coming from this electromagnetic field and electromagnetic wave family. So this new chapter reveals that family to you, that is electromagnetic waves. Electromagnetic waves. I feel it is not necessary, or it is not necessary to discuss all these matters again, because you have already done an assignment or your project over this chapter, electromagnetic waves. And moreover, as I already told you, in the new syllabus, many topics from this chapter are removed, and here from this chapter, what you have done in the assignment or the project, that only remaining there. That means what is electromagnetic spectrum, and what are the properties of electromagnetic waves in that electromagnetic spectrum. Okay, so you have already done that assignment or the project, so you are familiar with those electromagnetic waves and their production, their range and their uses. That only now remaining in this chapter, means according to the syllabus. So you have already knowing these concepts. Anyhow, just take it as a revision, and we will discuss about electromagnetic spectrum now. Okay, so we are officially starting with the chapter electromagnetic waves. EM waves or electromagnetic waves. So as I already told you, we can start with the special characteristics of these electromagnetic waves. First common property, as I already told you, all are generated from accelerated charges. All are generated from accelerated charges. They can travel with a velocity of light. Why they can travel with velocity of light? Because light is also an electromagnetic wave. So electromagnetic waves can travel through vacuum with a velocity 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second. Third property is there in the second property itself. They can travel through vacuum. That means it is not necessary to possess a medium to travel through. It requires no medium to travel through. And electromagnetic waves, electromagnetic fields. Electromagnetic fields are perpendicular to each other. It is generated from cross electromagnetic fields, and this magnetic field and electric field are perpendicular to each other. Moreover, as I already told you, from electromagnetic waves, electromagnetic radiations are coming out. So the direction of propagation is perpendicular to both electric field vector and magnetic field vector. Which means, suppose you are having electric field acting along x direction, magnetic field acting along y direction, so propagation should be in z direction. So this is the direction of propagation of electromagnetic wave, which means electric field and magnetic field are perpendicular, so propagation also perpendicular to both electric field and magnetic field. So that is another property. And in free space, whenever electromagnetic wave is traveling through free space, its velocity c is given by E by B. That is, E is the electric field intensity and B is the magnetic field intensity. E is the electric field intensity and B is the magnetic field intensity. Then energy of an electromagnetic wave is divided on the average equally between electric field and magnetic field. I already told you there is an in electric field and magnetic field, they possess energy and that energy is liberated. So energy is equally divided between electric field and magnetic field. Energy is equally divided in between electric field and magnetic field. And energy density is given by energy density, that is energy per unit volume. Energy density in the electric field is given by 1 by 2 epsilon 0 into E square, and this is in the average energy in the electric field, and in the magnetic field it is 1 by 2 mu 0 into B square. 1 by 2 mu 0 into B square. That is 1 by 2 mu 0 into B square. 1 by 2 mu 0 into B square. And again it is given that C is equal to 1 by root of mu 0 epsilon 0. C is equal to 1 by root of mu 0 epsilon 0. And the electric field vector is responsible for the optical effects of an electromagnetic wave and is called light vector. So when you are talking about visible light, that is visibility of light is, visibility of the electromagnetic wave is given by or due to the electric field. So electric field is also known as light vector. It is also known as light vector. Then electromagnetic waves, they are generated from electromagnetic field. As I already told you, they are generated from electromagnetic field, but they are not affected by, they are not electromagnetic waves, they are not affected by electric field or magnetic field because they are not charged particles. They are not charged. Electromagnetic waves are not charged. Okay, so these are the common properties of electromagnetic waves. See, electromagnetic waves, they are having some common properties. So they are arranged in the form of, and moreover, the properties of wave that you have already knowing, that is frequency, amplitude, wavelength, all these matters we are having. And lambda and frequency are, lambda and nu, wavelength and frequency are inversely proportional. Lambda and nu are inversely proportional. As lambda increases, nu decreases. As lambda increases, nu decreases. Okay. So these electromagnetic waves are arranged in a systematic way. These electromagnetic waves are arranged in a systematic way. They are either in the increasing order of frequency. If it is increasing order of frequency, obviously that should be decreasing order of wavelength. Okay, so you know that if it is in the increasing order of frequency, it is in the decreasing order of lambda. So such an arrangement of electromagnetic waves, either in the increasing order of frequency or decreasing order of lambda, that is known as electromagnetic spectrum. That is known as electromagnetic spectrum. See, electromagnetic spectrum starting from radio waves, then microwaves, infrared, then visible light, simply you can call it as light, visible light, then ultraviolet, X-rays, and gamma rays. You have to remember this order. This is the order of electromagnetic spectrum, ranging from radio waves, microwaves, infrared, light, ultraviolet, X-rays, and gamma rays. In some classification, we can have amplitude modulated waves also. It's a special kind of electromagnetic waves. Anyhow, amplitude modulated wave, but it is not a basic electromagnetic wave. That is why it is not included in some books. But in some books, you can tell amplitude modulated wave, radio wave, microwave, infrared, light, ultraviolet, X-rays, and gamma rays. So this is in the increasing order of frequency. Frequency increases when we move down. When you are moving from amplitude modulated wave to gamma rays, that frequency increases. The frequency increases. Okay, so if frequency increases, obviously wavelength decreases. So you have to remember this order. To remember this order, some techniques we are using that in carbon resistors. Carbon resistors now it is not there in the syllabus. Okay. So in the carbon resistors, that color coding, to remember that color coding, we were having a sentence that is a baby Roy of Great Britain have very good wife. Similarly, here also I introduce a person to you. I will introduce a person to you. He is an army person, soldier, army person, and he went to a shop. Army person went to a shop and he bought one Lex and a pack of key. You know what is key. So army person went to a shop and purchased Lex and key. That is the mnemonics to remember this. See, ARMI, that is army. Person went to a shop and bought Lex and key. Okay, see, amplitude modulated wave, radio wave, microwave, infrared, light, UV, X-rays, and gamma rays. So that is the increasing order of frequency, electromagnetic spectrum in the increasing order of frequency. Okay. Okay, so that is electromagnetic spectrum, and when now you can introduce different members in that electromagnetic spectrum. So in your textbook, it is very clearly given what is the which are the members in the electromagnetic spectrum, and what is their wavelength range, and what is their frequency range, and how they are produced, and what are the properties and uses. Properties and uses are different. Some last year, I think, a question was asked, uses of electromagnetic waves. Many students written their properties, But remember, properties and uses are different. Or sometimes properties are asked. Suppose gamma rays. What are the properties of gamma rays? Some students are written that they are used for information about the structure of atomic nuclei. But that is only a use. That is not their property. You can easily find out the properties of electromagnetic waves. What are the properties shown by light? We will talk about in detail about the properties of light in the coming unit, that is optics. So whatever properties you can assign to the visible light, all those properties can assign to electromagnetic waves also. Why? Because they are coming from the same family. So properties to learn about the properties of electromagnetic, that is very easy. They can travel through vacuum. They can travel through vacuum with the velocity 3 Newton to the power 8. They can polarize. They can reflect. They can refract. Whatever it is, all the properties of visible light can be given to electromagnetic waves also. But you have to separately learn the uses of each electromagnetic spectrum. So when you are talking about gamma rays, its wavelength range is 10 to the power minus 14 to 10 to the power minus 10 meter. Gamma rays, its wavelength range is 10 to the power minus 14 meter to 10 to the power minus 10 meter. So corresponding frequency range is 3 into 10 to the power 22 to 3 into 10 to the power 18 hertz. It can be easily calculated. That is, E is equal to, or lambda is equal to, lambda is equal to that, we will come to that. Lambda is equal to C by mu. Is it? That is C is equal to mu lambda. So if you are, C is common there. What is C? C is 3 into 10 to the power 8. If you are knowing the lambda or mu, you can easily find out the other. If you are knowing mu, you can easily find out frequency. See, here we have said that it is 10 to the power minus 14 meter, the lowest one. So lambda minimum is equal to 10 to the power minus 14, 10 to the power minus 14 meter. And C is equal to 3 to 10 to the power 8. So when lambda is minimum, mu will be maximum. Remember that, because mu and lambda are inversely proportional. So that is 3 into 10 to the power 8 divided by C by nu. Nu is 10 to the power minus 14. Then you can easily calculate the nu max. What will be that? 3 into 10 to the power 22. See, if you remember, I always say that you have to remember either in the frequency range or wavelength range. Then the next one you can easily calculate. Then their production is by transition of atomic nuclei and decay of certain elementary particles, gamma rays. In radioactivity, we will talk about that. So properties: chemical reaction on photographic plate, fluorescence, ionization, diffraction, highly penetrating, chargeless, then harmful to human body. See, their uses are provide information about structure of atomic nuclei. Direct means nothing to explain there. You have to learn what is the wavelength range, frequency range, production, properties and uses. So X-rays, their range is 10 to the power minus 13 meter to 3 into 10 to the power minus 8 meter. That is the wavelength range. Their production by sudden deceleration of high-speed electrons at a high atomic number target. And also by electronic transition among the innermost orbits of atoms. So all the properties of gamma rays, but less penetrating are the properties. Then uses in science, they are studying structure of inner atomic electron shell. Then in surgical uses, X-rays, you know, in medical field many uses are there for X-rays. In engineering, detecting the cracks, flaws and holes in the finished metal products. Then radiotherapy to cure untrackable skin diseases and cancer-like diseases. Radiations are used. Then ultraviolet. Ultraviolet is, the wavelength range is 6 into 10 to the power minus 10 to 4 into 10 to the power minus 7 meter. Then their production: sun, arc, vacuum, spark and ionized gases. Then properties are again all the properties of electromagnetic waves. Then uses are detection of invisible writing, forged documents, fingerprints, and to preserve footsteps, to destroy bacteria, and for sterilizing the surgical instruments in burglar alarm in studying the molecular structure. So for these uses, ultraviolet radiations are used. Then visible light, you know what is visible light, and its range is 4 into 10 to the power minus 7 to 7 into 10 to the power minus 7. Then uses reveals structure of molecules and arrangement in electronics, external shells of atoms. Then sight, all these are visible light properties. Then infrared. Infrared is 8 into 10 to the power minus 7 to 5 into 10 to the power minus 3 meter. That is the wavelength range. Then their production from any hot body, infrared radiations are coming. Last year we have said we are oscillators, we are radiators. Black body. And by rotational and vibrational transition of molecules. Then uses are providing electrical energy to satellites by means of solar cells, for producing dehydrated fruits. Then fog or mist means infrared photography. That are the uses of infrared radiations. Then microwaves. Microwaves are 10 to the power minus 3 to 10 to the power minus 1 meter. Then oscillating current in special vacuum tubes, they are produced, and electromagnetic oscillators. Then in radar system used are microwaves. In radar, microwaves are used. Then radio waves, 10 to the power minus 1 to 10 to the power 4 meter. Then you see wavelength is slowly increasing. This is in the opposite order, starting from gamma rays. That means decreasing order of frequency and increasing order of wavelength. So radio waves in radio and TV communication systems, cellular phones, and radio waves to transmit voice communication, UHF, ultra high frequency band. Then long waves, that is actually amplitude modulated waves. So they are weak radiation from AC circuits. They are weak radiations from AC circuit, and the frequency range is 50 to 60 to 50 hertz. And the wavelength range is 5 into 10 to the power 6 to 6 into 10 to the power 6 meters. So that are the different members in electromagnetic spectrum, their properties. So already you have done this assignment as a project. Okay, so that is that only there in your chapter electromagnetic waves. Why this chapter is included there? Which means from this only you are taking any one of that electromagnetic member. Which one is that? Our visible light. The most familiar one, the most important one, visible light. And I already told you, we have a revision on the content that we have started with the syllabus, and now where you are, now this is the pathway to our new unit, optics. So from this we are picking up this visible light, and now we are going to talk about the properties of visible light. So during the next classes we will start with optics, the properties of light. But many topics from optics are also removed from your syllabus now. You will see that revised, I think you've already seen that is syllabus revision. So strictly follow the syllabus. Topics are there in the syllabus, and that only we have to learn for your boards. Okay, so anyhow, we will meet in the next class dealing with the properties of light. Okay.